Alright, so hello everyone. Welcome back to NUS GDG. And from this week onwards, we are going to be officially commencing level 2 games. Okay, so is anyone here not present last week? Okay, anyone here already has a team forming last week? Okay, these two are different teams, right? Okay, for the people that isn't here last week, you can choose to join one of the already available teams, or you can form a team yourself. So I'll give you guys like 5 minutes to figure out what you want to do. Okay, so as a quick disclaimer, level 2 games, okay, for this part of this is that I'm going to hold a weekly 30-minute workshop session, and then the rest of the time you have is going to be, discussing with your teammates, and then actually try to make like a half decent game. Okay, let's say that. Okay, so for this 30-minute workshop, I'll go through various different kinds of topics that is more specific to the Unity game engine, but it's also useful in terms of general game development. And some of the programming concepts that I'll go through, as well as some of the optimization techniques that are specific to Unity engine. So for this level 2 games, you want to form a group and you can create a game idea of your own. And I would assume most of you already have a little bit of experience from level 1 games or prior to joining level 2 games. And so these workshops would be a little bit more advanced in the sense that I won't be going through all the basic things like how you use GitHub with Unity, how Unity actually handles a lot of the physics mechanics, as well as how you can write the code in Unity. So if you're completely new, that's fine, because this session's workshop is going to be more easy. But if you're interested in continuing, I would highly recommend checking out the beginner's workshop recording that we had last semester. Okay, so I think a few people joined in. Alright, let's do a raise of hand again. Who isn't here last week? Okay, who was here last week and already had a team? Alright, cool. So again, I repeat, the people that wasn't here last week, you wouldn't have a team yet. So you can choose to join one of the existing teams, or you can form up a team yourself. Alright, yes. This is Unity. Godot is next door. It's 125, which is just around the corner. You're welcome. Okay, so I'll give you guys 5 minutes. Do you guys want to join the existing teams, or do you guys want to form out a team yourself? Okay, let's be productive. Of the people that didn't come last week, who wants to join existing teams? Who wants to form their own team? Okay, can't commit. Okay, who doesn't want to commit? Who doesn't want to commit? So it actually doesn't want to do the games, Okay. Yeah, quick, join some team. I don't think the rest of you guys can. Let's see. Okay, you joined that team, you joined this team. Okay, that's good. You guys have 5 already? Yeah. How many guys do you have? 3. Okay, then you join that team as well. So it'll be 5-5. You guys don't mind, right? Okay, sure. Cool. Okay, so with that sorted, since we are going to have a lot more access time this time around, I will leave the networking and ice-breaking session later. Okay, so these are the workshop topics that I'll be going through. It starts with an introduction to the 3D editor, which is this session. Next week we're going to have a game design workshop with the Godot people, okay, together. And then we're gonna go through player saves, finite state machines with the Godot people again. And we'll do pathfinding in Unity, lighting, shaders, profiling, as well as batching and level of detail, which is the more towards optimization techniques, and also comparison options, which also helps in the final, also helps with optimizing the final product. So the workshops will all be recorded and posted. All the slides will be sent alongside a link to the recorded workshop every week. I'll try to send the recording by usually by Friday. Yeah. And then I'll also provide a GitHub repository to the workshop project. From next week onwards, it will be in advance. But for this session, I'm pretty sure you guys probably wouldn't have this engine version installed. So the GitHub repository would be in Unity 2022 17F1. So it's the latest version that I get by the time I started making level 2 workshop preparations. Alright, so without further ado, I'm going to go through the introduction to Unity 3D. And, okay, let me sit down. Essentially, it's practically the same. Have I not launched it? Okay, I have not launched it. Okay, essentially it's practically the same as how the 2D editor is. And by convention, you make 3D games with it, and it uses a very similar scripting APIs as Unity 2D. The only difference is that for most of the physics related stuff, you remove the 2D suffix and it becomes the 3D APIs. So rigid body 2D is rigid body, box collider 2D is box collider, etc. So it just practically the 2D version is just a squash 3D game engine. Yeah. So the required specs that you are going to need to run the 3D editor is a CPU. For x64 architecture, it will require SSE2 support. If you're on Apple Silicon, you should have this already. If your computer is not from 2005, you should have this also. Yeah, come on in. Okay. And you should also have a graphics card. I would recommend having a discrete graphics card, okay, that supports DirectX 10, DirectX 11, DirectX 12 APIs, or Metal if you're on Mac, which practically is just any computer that's released in the past 8 years. Yeah. So to set up, first of all, it's like how you would start any Unity project. You click on New Project, right? And then there will be 3D projects available. There's the 3D, the base one. There's a 3D URP, which stands for Universal Render Pipeline. I'm gonna go through what that means. There's mobile, which is specifically optimized for mobile programming. So if you want to make a 3D game for your phone, you can do that. There's also 3D HDRP. So this is called High Definition Rendering Pipeline. Again, I'll go through this with URP later. So some other ones are like mixed reality, VR, AR, mobile, for this, I'm not going to go through that because, it's a little bit more troublesome. So eventually you'll start a project. Again, you give it a name, you give it a location, you store it somewhere, and that's basically it. So the differences between URP and HDRP is that Unity right now provides 3 built-in rendering pipelines. Okay, the first one is the standard one, which does not have a URP or HDRP. So this is what we have been using last semester in 2D games. Okay, we didn't use URP. For URP, it stands for Universal Render Pipeline, and HDRP, it stands for High Definition Rendering Pipeline. So URP and HDRP are scriptable. What it means is that you can have a much better control of how the game actually renders through the use of C# scripts. So it will be a little bit more advanced and would especially be useful if you're trying to make any kind of stylized games. So if you want to make it realistic, you can do that. You want to make it more cartoonish, you should use URP or HDRP as well. And each rendering pipeline has a different visual target and use cases. So they actually produce slightly different visual impact as to how the things look. So for a very simple comparison here, the standard one is just as standard as it can go, is the classic Unity look. It's the old way of rendering, and Unity is trying to phase this out very soon. It doesn't have very many features, and it's good enough for small projects. So if you don't want to make it very large, you just want it to be like a very casual 3D game, yeah, go ahead, use standard. So you don't have to go through a lot of the mess on, you don't actually have to go through all the features that the other rendering pipelines provide. URP, it includes many customizable features. It has more fine-tuned control over rendering, and it has a little bit more performance optimization than standard, and it's generally good for stylized games and most titles in general. The thing about URP is that you have more support with shaders, which is one of the more advanced graphical concepts that we have. We'll go through that in the future workshops. So, yeah. And for HDRP, it is the advanced way of rendering. Unity introduced this in its 2019 engine version, and you can use it to create AAA titles. So as you can see from the screenshot, it's like some very realistic jungle forest scene with light rays coming down, the Hall effects and everything. So it's mainly targeted for realistic graphics. It has a very high system requirements because, as you can see, the graphics is very powerful, and it's generally suitable for double or AAA titles. Alright, so setting this up, we won't be going through scripting the rendering pipeline. That's a lot of work, okay? And unless you already have some basic in computer graphics and how the rendering pipeline actually works, you probably wouldn't want to touch it. But our workshops will be carried out in URP pipeline because it has wider support for lighting, more optimization options, as well as support for shaders and shader graphs. And there's this manual docs that you can read out. Okay, so without further ado, let's start. Okay, this is a sample scene that I made. I know it doesn't look that good, but it's sufficient. Okay, so as you can see, right now, in this editor, all game objects are 3D. I don't think I need to say much about that. So, yeah. There's now an additional axis called the Z-axis that is used for the depth. So it kind of looks like real world now instead of being squashed pixel art or whatever. Yeah. So for physics, again, components, they no longer have a 2D suffix. And there are additional colliders, such as a capsule collider, which is usually suitable for humanoid players, and mesh collider, which follows the shape of a 3D mesh. A mesh is kind of like a 3D model, for like the more scientific term for it, okay? And character movement can now be controlled with something called a character controller, and also you can use movement scripts. The thing about character controller is that it has colliders already, and but you have to define kinematic physics for it. So instead of having a rigid body do all the work for you like you did, if you want to use a character controller, you have to write the physics, for example, the gravity physics and everything. I'll go through this. Okay, so right now, for our player, I have this character controller attached to it. So if we do something as how we would usually have done in level 2 games, we would have a normal player movement script. Okay, so let's open it up. So it looks fairly similar to how we wrote it. Essentially, you define a move speed, some jump height, and you want to refer to the character controller. You kind of replace rigid body with character controller. Then you have a vector for velocity and move. Yeah. So that you can get the input, and then you can pass the input in for some form of movement. And then you have grounded, which saves whether or not the player is actually on the ground, so you can know whether or not you should jump. So on the start, you get the character controller component. Then as you update, you're going to check if the character controller is grounded. So there's the controller.isGrounded property that you can refer to, you can take a reference from. And basically it tells you whether or not the character controller is on the ground. So if the base of the collider on the character controller is actually touching something on the ground, it will return true. If it's not, it returns false. So there's apply move, apply rotation, apply gravity, which basically just moves. This one takes the input. So something to take note of is that now that we have kind of a three-dimensional, up and down usually in games, the up and down axis usually means that you move forward or backwards, right? So, but when we take that as an input, the vertical axis, we would usually think that it's the y-axis. But the y-axis is actually the height in Unity's world building. So if you want to make it move forward and backwards, you should put that in the z component. So this is the vector tree for move, and then you can see that the horizontal is in the x direction, left and right. And then the vertical, which is forward and backwards, is in the z direction. And for the y component, we are not going to put anything. Okay, we're not going to put anything for now. It's usually used for jump. Okay, and we move that. So you can use the controller.move, which is also a new API for the character controller. If we do this, we'll be able to move it in a certain direction. So in this, it's just going to reflect to the absolute direction of the inputs, and it's not going to have some form of camera viewing and everything. I didn't set that up. So time.delta time, because this move is actually moving the absolute position instead of increasing the velocity of this object. And then times the move speed. I think this is quite basic if you have been through Unity programming so far. So for rotation, you want to rotate the object to where it's moving. It's kind of like you're facing where you're moving, but you move where you face, right? So if move is not 0, you just transform the forward to wherever the move vector is. So it's quite easy here. So this forward means that like where the object itself is actually facing. So if we change that to where it's moving, to the move vector, it actually just means that we look at where we move. It's that simple. But what's new here is that we need to define our own kinematics physics. So here is to apply gravity. And you can see that we predefine a gravity constant, which is negative 9.81. Usually accurate enough for games. Okay, don't sweat the details. So you just add the gravity component to the character, to the character's velocity, whenever you kind of when it's supposed to actually do it, like all the time. So you can see that apply gravity is actually here. It's in update, right? So the rest of this is quite similar. So we want to move the controller to that velocity. So we want to move it downwards every frame. But if it is grounded, and the current y velocity is smaller than 0, you want to assign it to 0 so that it doesn't do some kind of thing like clip through a terrain or whatever. And jump is just to, do velocity.jump height. So that's about it. And if we look at how this script actually looks like, is that hang on. Did I apply it? Okay, I need to give it a speed and a height. Okay, so it works, You can see that it's rotating towards the direction it's moving. And I can move around this 3D plane. So that's good enough. But there's also something new. So aside from the character controller, right? As I said, there are capsule. This 3D mesh is actually built into Unity. It's called a capsule object. So if you create a 3D object, you can see this capsule here. It's usually used for humanoid. It's usually used for prototyping of humanoid characters. So if you don't have a human mesh yet, you can use this capsule because it represents humans quite a lot, I think. Yeah, I think. Anyways, so for the rest of it is that you can have a capsule collider as well as a mesh collider. So when you import a custom mesh, it may have irregular shape that you can't just use boxes or spheres to actually make the collider. You can use mesh colliders to put it on. You understand it once you actually get custom models. Alright, so besides that, there's also a new input system that you can leverage. So this new input system is introduced in Unity 2019 as well, and it's more flexible than using Input Manager. It has less overhead than Input Manager because the input system sends an event when an input is detected instead of having your script to check if an input is there every single frame. And it can be installed through the package manager. So how you can install this is you go to Window, Package Manager, and in Unity Registry, if you search for input, you would find this input system and you can install it. I've already installed it on this package in this project. Yeah. So the way how this works is that you want to create a new input action and you name it something. Okay, I'm just gonna name it test for now. So for this input action, you can define any kind of input that you want to have. So in this case, you have to start with an action map. So action map is the set of available inputs that is available, and you give it a name, right? So for example, if this is player. So once you define this action map, you'll be able to add actions to this action map. So this is called a new action, and if we want to make it, for example, the move, okay, we're gonna put this move, and you can change what kind of action is supposed to be registering. So there are 3 types of action it can register. The first one is that it registers a button press. The second one is that it passes some kind of value to some method. And the third one is that it returns a value that can be used in the method. So usually you would go with value, and the control type here is the list of all available inputs that you can put. So it ranges from any to analog, which is not just digital 0 and 1s. Axis, which is usually used for joysticks. Bone, I don't know what this is used for. Button is a normal button. Then delta, which records the difference between the previous position and the current position of something. Digital, which is 0 and 1. Discrete button is, again, it's similar to button. And a lot more here, but I'm going to stick with vector 2. So vector 2 is just a 2-dimensional vector. It has an x and y component, and is usually good enough if you want to apply any kind of movement or record any kind of movement that happens on your keyboard. You know, usually we press WASD in a game, so you would use a vector 2 for that. So once you add that, you will be able to add more bindings. These are the keys or the type of input that the action is expecting to record. So in this case, this one is not that useful. So we're going to add this one, an up, down, left, right composite. So what this does is that it's going to record 4 keys, and then it's going to add all the values of these 4 keys together and form an up, down, left, right composite, which is used as the x value and the y value of a vector 2. So let's add that. As you can see, it's already a 2D vector. That's the composite type that we want. And you can change these based on whether or not you want analog keyboards to work or something that similar. So for this up, we're just gonna bind that to the keyboard and location of key. Unity, please. W. Right. So that indicates the up key on the keyboard. Down is similar. You're gonna use S. Yeah. Left is A. And then right is D. So once you have this set up, right, you'll be able to use this input action in for your character. So for example, here on this player, what you need to do is to attach this action you want to add a player input component, and then you can attach this action, like this action, onto this player input component, and then have a default map. So the default map is going to be the map that it initializes with, and you can change this dynamically in runtime. So for example, if someone changes their input from keyboard to joystick, you'll be able to change it dynamically as well. You just need to make sure that you actually define the set of input actions correctly. And after that, you want to change this to invoke Unity events, so that these will only invoke the events when it's required. And then we can head on to write the scripts, which is here. So this is exactly the same as the previous one, but this time we add the new input system into it. So you can see that all of these are exactly the same, but we have move and jump here, which indicates the event that Unity needs to catch in order to register this new input. So we want to accept input.action.callback_context as the argument, as the parameter. So basically, this context is going to be whatever value that is obtained through this input action. So if W is pressed, this context will contain the value of the W in the up component, for example. So in this case, we can read the context as a vector2 value. We pass that into input. And then we will be able to just change the move vector to X and Y. So we no longer need to, figure out what's the horizontal axis, what's the vertical axis. You just need to define it in the play action. Setting up is more troublesome, but it pays off, I think. Yeah. And then same thing for jump. And then for this it's just the same, right? You add jump height, but if it is grounded, we don't want this action to invoke anything, so we just return. So if we look back here, I put this in the player controller action, and if we look at this, again, the move is a 2D vector with WASD bind to it. The jump is a button that checks for space. So when space is pressed, it's going to jump. Yeah, it's that simple. Okay, it's not that simple. So after you have written the script, you want to go to the input, open events, and then if you click on player movement, which is the default map, you'll be able to register the type of events that it has to listen to. So in this case, move is going to listen to player, and you need to attach the new script to it. Which one was it? Okay, it's this one. So you attach the new script to it, so now it has the new input system script. Let's remove the previous script so that it doesn't cause a conflict. So you invoke this event, which is player movement, move, and then you drag this in again. You invoke the jump event for the jump callback context. Now all you need to do is save and everything works. What's cool about this is that now you can define many types of different input with the same script. So in the script, you don't need to differentiate between, oh, is this on joystick, is this on keyboard, or is this on some kind of different type of controller? No. All you need to do is to write the script once and then configure the correct input actions for all the different types of controls that you want to support, and then you can just use the same script. As long as it calls the same callback context, it has the same return type for the context, it will all work. So this is what we mentioned by flexibility. It supports all types of different input, as you can see here. Like when I say a lot, it's a lot. It supports XR input, VR input, pointer, pen, joystick, mouse, whatever that you can think of that can be used as an input can be found here. Usually, yeah. Unless you're trying to use some very interesting things. I don't know. Okay, so far so good. Is it okay? Okay? Yeah? Alright, I trust you guys. Cool. So, the other thing about 3D is that now we no longer have colors. Like, you can't just assign a color to an object and then expect it to look in that color. Every mesh has a material property that defines what color it looks like. It also defines how transparent, how translucent it's supposed to be, and also how shiny it's supposed to look when a light shines on it. And these materials, they are generally used for lighting computation. So let's take a look about it. So if you look at player, in this mesh renderer here, there's a material drop down that you can open up. And here, all Unity default meshes would have this lit component attached to it, which is just this color. It's very basic, it's plain white. Okay, it's not very interesting. So what you can do is that you can actually add more material to it. Okay, for example, I created a new folder called materials here, and you can create a material, give it any name, and then you can change the material property here. So there are two types of properties. The first one is metallic, the second one is specular. So metallic, you're going to have a little bit more metallic feel to it, so it looks like a metal. It has brighter reflections. It has more, it just gives you that feeling that it's actually metal. Okay, I'm not sure how I can describe that. Specular, on the other hand, makes it feel like it's just a normal smooth surface, like the table in front of you. That is considered a specular material. So if we select this, on the surface type, you can change you could choose whether if it's supposed to be opaque or transparent. So if you want a translucent object, it has to also be transparent. It's just a different alpha value. So let's go with opaque. And the render face, front, both or back. This one is generally not that important. You usually just keep it in front or both, depending on how the visual effects you want it to look like. So here you can change the color of this material, where you have a preview down here, like this. And you can also change how metallic it's supposed to look. It looks a little bit more like bronze now, I think. How not metallic it's supposed to look. How smooth it is supposed to be. The smoother it is, the sharper the specular highlight is going to be. The specular highlight is this white dot here. Okay, when it's not smooth, the light doesn't reflect well. If it's smoother and smoother, the light reflects very well off of it, and it becomes clearer and clearer. And this source here, yeah, it's okay, you don't need to care about that. So yeah, usually this is what the material is used for. You can define differently, and then you can attach this material onto a mesh. Now the player looks different. So no more messing with colors, you mess with materials now. Okay, which honestly is not any easier. And finally, textures. So materials only define colors, right? Like, what if I want it to look like it's got some details on it? Like, I'm a professional artist, right? I'm supposed to make a model that has very cool details on it. And the way how you do this, if you're a 3D artist here, you should know what I mean, is to attach a texture onto the map, onto the mesh. So textures are image files. They're like sprites in 2D game development. And eventually, it's just trying to put this image file, you map it onto a 3D mesh so that it looks like a skin on top of the mesh. And it's used to give color details to a mesh. So for this ground, right, if you open this up, this is just essentially a plane, which I put this Untitled 1 material onto it. So this material has a base map, which is essentially the texture that I have created. So the way how you can attach it is that you create a material, and then you go and find your texture here, and then you just drag the texture onto the base map, and boom. Now this material has this texture on it. And if we attach this onto our player, okay, not this one, the material, it will have this texture onto it. So you can include a little bit more details to it. And just as a side note, I'm just saying this, if your team has a 3D artist, you want to make your custom, like your own custom 3D mesh, the way how you do it is you go to Blender or Maya. Okay, I don't know how to use Maya, so I use Blender. Once you have this texture map, you're going to export this image as its own texture file, which is just an image file, like a PNG file or JPEG file. And then you want to export the model here as an FBX file, as an FBX archive. So saving it as an FBX archive allows you to import this into Unity as a custom mesh. It's going to be a prefab of everything on it. It will have the material that is already attached to the mesh. It will have the mesh data. It will have the mesh data, yeah, and any kind of camera or light that you have attached onto the scene in Blender, as well as animation, if you actually did the animation in Blender as well. Okay, so I believe that is almost all. The last thing that is different in 3D is that the cameras are different. So by default, the cameras in a 3D project are perspective. So the way how perspective works is that if you look at this, it's going to shoot multiple light rays that converges onto the camera in 4 different directions to create this image. So it's going to have this effect that things that are further away from the camera appear smaller. Things that are closer to camera appears larger, because they will take up more space when the light converges into it. So it's kind of like how we view this world, the reality right now. Orthographic cameras, on the other hand, they do not converge the rays, so they actually shoot parallel rays into the camera, and so everything appears 2D. And regardless of how far the object actually is from the camera, it's always going to appear in the same size. This has something to do with how optics work, but I'm not going to go into that. Alright, that's actually it. Any questions? Okay, I know it's like a huge info dump, but it's okay, I think. Alright, so 3D game development is very complicated, and you have a recording, so it's fine, I think. Alright, any questions? No questions. Alright, so if there's no questions, I'll end this workshop session here.